The new chapter for the session is chapter number 6, which is lines and angles. As we have discussed in the previous chapter about Euclid's contribution to geometry, we have come across various axioms, postulates, and many things connected with lines. So those properties of lines which you have studied in Euclid's contribution is what we're going to extend in learning the connection between lines and angles and various further properties connected with lines and angles. As we have discussed that a line is a unique line which passes through two distinct points, now comes how an angle is connected with the line, is what we are going to discuss in today's session. The lines connected with angles. As we all know that angle is part of two lines, we know what an angle is. So let's see how we connect an angle with the straight line. Imagine I have two lines which are intersecting, the line L1 and the line L2 intersecting at this point. Now my question here is, what is an angle? How many possible angles are existing when these two lines L1 and L2 are intersecting at a point P? I find that there is an angle out here, there is an angle out here, there is an angle out here, and there is an angle out here. So totally there are four angles, 1, 2, 3 and 4 is how I understand the lines intersecting to form angles. There are angles out here which are formed by the two lines intersecting. Let's see the continued properties connected with lines and angles as introduction, continued with the session. Now that we have learnt about the introduction of lines and angles, there are some basic terms in the topic which we need to understand before we get into the concept of lines and angles. The basic understanding of the basic terms. So let's see what are the basic terms as used in the topic lines and angles. Initially with the basic terms as used here. Now as that we are defining a line or an angle which is derived from a line, the source of an angle is a line, is how I understand. Therefore, it is very important that we understand the different forms of line representations. Say for example, I have a line which is this, with the endpoints A and B. Then this is called line segment AB. I call this as line segment AB, is how I understand this. Next, say I have a point A, but I don't have the end on the right, or I have point B and I don't have an end on the left, or I have point C, or I have none of the points in between, but it doesn't end on the right and left. These kind of lines which do not end on the either side or on the both sides. Here it doesn't end on the right, here it doesn't end on the left, and here the line doesn't end on either side. Such lines are called rays. I call them rays. A light ray which passes, imagine I take a torch and pass a light ray, it never ends, it goes on and on. So we call this as a ray. The right ray, the left ray, the two end ray is how we define the subterms. So it's very important that we understand the line segment AB and the rays AB before we understand the line AB. Line AB is a line which can be a line segment or a terminated ray on one side or non-terminated on either side. Is how we understand the basic terms which are essential in connecting lines with angles. Now that we have seen some basic terms essential for understanding lines connected with angles, it's also important to understand some extended basic properties like the collinear points or the non-collinear points on the line. So what are collinear and non-collinear points is what we're going to discuss in this session. Collinear points. When do we say collinear? When they are linear to each other. So when are the points linear? If all the points lie on the line, they are collinear. If all the points do not lie on the line, they are not collinear. It's very simple. The word collinear itself says they are linear, therefore we have collinear implies all points must lie on a line. Then only we say the points are collinear. Say for example, I have a line, or this is a ray in which I have 3 points P, Q and R. Let's see if they are collinear. Clearly I have the point P on the line L, and I have point Q which is on the line L, and the point R which is on line L. So since PQR lie on line L, therefore they are linear to each other. Therefore PQR are called collinear points on L. The points are collinear if they lie on the line L. They are not collinear if they do not lie on the line L. Is how we understand collinear points connected with lines and angles. Let's see an example of a situation where we have non-collinear points. For example, I have a triangle ABC. I clearly see that if I take this line L, A and C lie on L, but B does not lie. Since A, B, C do not lie on the same line, since A, B, C do not lie on the same line, therefore A, B, C are non-collinear. Is how we understand the non-collinearity of the points. The 3 points must lie on the line L for the 3 points to be collinear. If one of the point does not lie on the line, though the other 2 points lie on the line, all the 3 points are said to be non-collinear. Non-collinear do not lie on the line. Collinear, the points lie on the line L, is what we learn as the learning outcome.